This video describes how to apply and where to apply Python's unit test mock patch. What it does is it enables you to substitute an object with another object of your choice. For example, if you have a network call that you don't actually want to run in your test suite, or if you have a subprocess call that you don't actually want to run on the system. These are both great situations to use a patch. So unit test's mock patch requires just one positional argument, which is the target of the patch. The format of this is package, module, class, or function name. And it's really important to remember that you need to mock not where the object is defined, but where it is used. And those might not be the same place. And we'll see an example of this later. Two of the keyword arguments to mock.patch that you'll probably use the most often are return value. This enables you to specify the return value of the function that has the patch applied. This is one of the main ways that you can simulate different behavior. So in this example, the return value is the string tee. Side effect is another common keyword argument that you'll use, which enables you to perform side effects. So for example, here we're using the side effect keyword argument to raise an exception. Now we know how to define a mock. Now we need to learn how to apply the mock. We need to ensure that a mock is started prior to the test run and that the mock is stopped after the test completes. There are three main ways to apply a mock. One is using a decorator that can be applied at either the method or class level. The second is by using a context manager. And the third is by applying the mock inline, and that involves manually calling start and stop on the mock patch object. So let's see each one of those in turn. Here I have a very simple program that simply has one function, and this function returns the contents of the current directory. So it uses subprocess check output to call ls in the current directory, and that call will return, as in Python 3, a bytes literal that has the files and directories in the current directory. So then we call split on the result. That creates a list where each element of the list contains a single file or a single directory. So let's take a second to observe the structure here. So we have a package project that contains a module fs. That's the file we're looking at. We have a separate directory tests that is at the same level as project, which contains our test suite. And right now that consists of a single file, test fs.py, and that contains one test case. Let me get rid of that, which will run the single function in the package code. So let's go ahead and run that. The test passes. What is it doing? We're running the single function, we're saving the result, and we're asserting that a directory that we expect is actually in that result. So we expect that tests will be in that result because we're actually making that subprocess call right now. Let's fix that. So the way we can do this first is using the decorator method. So we run mock patch as a decorator, and we need to figure out what the target should be. So let's look at our function. Is it subprocess.checkOutput? No, it is not. That is where the function is defined, not where it is used. So recall I said at the beginning, we want to mock functions where they are used, not where they are defined. And in this example by construction, those are not the same place. So to mock that call, we need to mock project fs check output. So let's do that. Package, module, and then method, function or class name. So it is check output. And then let's have it return. So I said it was going to be a bytes literal. So it's going to return foo and bar. And then we want to assert that, let's say foo is in that result. And here's an important thing when you use the decorator. You need to then pass a name for this mock into the function. So we'll call it, I don't know, mock check output. Okay, so this looks good. Let's now run the test. It failed. Mock is not defined. Bam. Okay, so that passes. So that's how you use a decorator to mock an individual function. If we want, we can move this to the entire class, which means that this function will be mocked for any test running in this class. We still need to pass in this argument though. So that was the first method. Let's now try to use the second method here, the context manager. So now to change the application here to use the context manager, we're going to take this, delete the decorator, and then we're going to run this actual print contents of CWD function with this patch applied. And we don't need this argument anymore. So it's really that simple. The nice thing about it is the method that has the mock used has very little vertical separation between its call and where the patch is actually applied. Let's test that works. Indeed it does. So that's the second method. Now the third method is using start and stop on the mock itself to apply the mock inline. So two of the pain points with the previous two methods is if you're in a code base that's doing a lot of mocking in the test suite, you'll have either a ton of decorators where you're passing in the mock objects as arguments to individual test methods or functions, or if you're using the context manager, then you'll start to have crazy levels of nesting if you're using the context managers, or you're going to have a mix of the two, which is kind of ugly. So in those cases, you might want to apply the mocks inline. So the way to do that in the test case, in the unit test library, is to use unit tests setup and tear down. So if you're not familiar with setup and tear down, these are special methods in unit test that will run a bit of code before for setup and after the test is complete for tear down. And so that's a place where you can start and stop the mocks respectively. So this object here, we're going to put into setup. We'll get rid of the nesting on this bad boy. And then we'll keep a reference to this patcher so that we can then call stop on the patcher later. So our patcher is this. Let's call start on this patcher. And then we're going to stop the patcher in our teardown. Okay, so we're starting it and we're stopping it. And it's very important to make sure that you are indeed calling stop on this patcher, otherwise you're going to have a lot of very confusing behavior. Okay, bam, that passes. So that's how to apply the mocks inline. Great. So in this video, we learned how to use unit test mock patch in our Python test suites. I hope this was useful and thanks for watching.